ATF? What were the XBP ones?
That was, I believe that was the specific, oh, they mentioned it and they said that was, I can't remember off
So
the top
it-
of my head, but it was,
When ATF4,
oh, it wasn't, is ATF4 cleaned at one point? No? I'm not sure.
so, anybody else? What's
I
XBP
think you
ones?
mentioned it.
What are the XBP ones?
I think you mentioned it, I think, in the, at the bottom of the figure, document, the article. Yeah, I think, right under the, what? Is it one of the kinases? No.
It's not just the control, is it?
Not in this case.
I believe it says it under the.
So what are the XBP ones?
Does it say that?
I'm not seeing anything completing.
Is it just a binding protein?
cDNA? Is that what it is?
Close. So these are going to basically be what's going to be activated when you are going through a stress
Stress,
response.
okay.
So these are activated.
Because they're
and
controlled.
Right, right. And so you're going to still see these being produced. So this is not what is inhibiting sort of this whole process of stress response.
So is that showing kind of, is it acting kind of as a control to show that this is gonna be produced when you're under these two stress conditions? Or not a control, but to, like, to show that these stress conditions are causing a response?
So this test is mainly to figure out, so we know that it inhibits PERK, so it's inhibiting sort of that process, but they want to understand, out of inhibiting PERK, what sort of downstream events are affected, and how is the whole stress response affected. And so initially you say, okay, PERK, the phosphorylation of it, isn't affected. We know that you can't make ATF4 now, okay? The XBP1s, those are actually the proteins that are your regulators that you're going to be making. And you still see you're able to make those regulated proteins. So it all is relating to this ATF4 that you're focusing on at this point. So that's really what this is laying out. Okay, is the phosphorylation? No. Is it these regulators that you would then be making more of because you had all this misfolded protein? No. Is it ATF4 production? Yes.
And then we previously went over that slide and showed that it's not the L2 alpha phosphorylation either that inhibits the ATF4 production.
So next they wanted to see, since they realized alpha-2 alpha is still being phosphorylated and so is the PERK sensor, they wanted to look and see if there are more downstream effects that RIP's affecting. So they looked at the global translation attenuation. So normally if you're not under stressful conditions, which are illustrated in the first half of the graph, you'd have normal protein synthesis. So methionine was tagged and was used to monitor how much protein is being synthesized, since methionine is always present at the beginning. And when you're under stressful conditions, it shows that less methionine is present, so there's less protein synthesis, less proteins present. But whenever you add the stress, add RIB to your stressful situation, your methionine levels go back up. So it's showing that this RIB is actually able to allow for regular protein synthesis to occur and for to have the same response as if you weren't in a stressful situation.
And they already said this, but I want to see for the audience, why is methionine the best amino acid to use for these type of tests?
It starts the chain.
So if you think about any DNA, how do you know to start that sequence? It's AUG, which encodes for methionine. So no matter what the protein content is, you're always going to have methionine. So it's a good measure. Instead of saying, okay, well we're going to use, say, tryptophan. Well, tryptophan content can vary depending on the protein. Here, you're just looking at methionine. And methionine is usually a rare one that you're not going to see throughout a whole structure, but you will see it at the beginning. So it covers all the proteins being made. Good.
So overall, to summarize just what we went over so far, they realized that the RIB actually isn't inhibiting the IRS, but rather is just preventing the cells from responding to the IRS, which is pretty interesting. So from there, since they realized that L2 alpha is still being phosphorylated and this, the rib isn't affected or doesn't respond to this, they wanted to see if you change the kinase that's phosphorylating the L2 alpha, if this has an effect on the ATF4 production. So when looking at the HRI, they realized that the PERK is still being phosphorylated as expected, but ATF4 production is decreasing. So this kinase had the same effect as the other one previously studied. And then they looked at amino acid starvation, which is another way to induce ER stress. And they realized that the PERK, once again, still being phosphorylated, but ATF4 production is decreasing. So no matter which kinase you use to phosphorylate L2 alpha, the rib is able to still prevent ATF4 production.
Okay, so then, as we said before, your ATF4, it is a transcription factor, and it regulates a whole transcription network. And so, as said at the beginning, when we went through the phosphorylation cascade all the way down to the bottom, the last step was when this ATF4, it works together with CHOP and our GAD34, and it activates these two transcription factors. And these two are transcription factors that allow us to respond and still survive under stressful conditions, because these are the mRNAs. So the next test they wanted to see is that does our RIB inhibit the production of our CHOP and our GAD? Their prediction was that it was going to, because these two are controlled by our ATF4 production. And as they found, it definitely did inhibit the production of these two through the inhibition of your ATF4. And as seen here, it's just like it's showing the fold change, and this is your CHOP and this is your GAD with presence of your RIB in these two columns.
And in this case, the control is when you're already under stressful conditions. So you're under stressful conditions and then you add the rib to it. And this is more just of a visual, which is
Right,
kind of, yeah.
right now.
Which one? I can-
Is it the top?
The bottom.
Okay, so this is more just of a visual aid. So whenever they luminesce CHOP, they use actin because DAPI would be in the nucleus.
No, they use DAPI in the next test
Yeah.
we're going to talk about, but they just use actin to identify where the cells were located.
So in the control, CHOP isn't present because you're under stressful conditions. Then when you add TG, you're under stressful conditions, CHOP's being produced because ATF4 is being produced through the integrated stress response. But then whenever you were to add RIB, you actually prevented the production of CHOP, which was shown in the data previously.
You can leave the lights on.
Okay.
And then, so then the next thing that they wanted to test is whether or not this RIB will affect the other sensors. So in the first slide we showed with the phosphorylation events, we had the three different sensors. You have your IRE, you have your ATF6, and you have your PERK. Now, up to this point, we've been talking a lot about PERK, but now that they wanted, since they already looked at the whole phosphorylation cascade that is caused by PERK, now they wanted to see, does this RIB have any other effects on the other two sensors that they haven't looked at yet? So what they did is they studied the effect of RIB on IRE1, which is another sensor. And so this is your stressful condition, and this is your stressful condition with your RIB. And you can see, so what they're measuring is the tiny little dots. And this is, you can see that there is no decrease, and therefore the RIB did not have an effect on this sensor. And then the other sensor they wanted to test was their ATF6 sensor, and if the phosphorylation and the activation of this sensor was going to be inhibited or not by RIB. And as shown here, you still have your ATF6 present with your stress in your RIB, showing that the RIB did not affect this ATF6. So up to this point, the RIB has only affected the PERK sensor, not the ATF6 or the IRE1.
So previously, different studies have shown that when you inhibit the phosphorylation of the L2 alpha, this reduces the viability of cells. So to kind of see if the RIB also has the same effect, they wanted to test to see if, when adding rib, if you increase the risk of apoptosis. So, as you can see from the control, there's minimal apoptosis, and they studied the caspase 3.7 because this is a protease, so the higher levels of the caspase, the higher risk of apoptosis, or the more apoptosis is occurring. So whenever you add stressful situations, the level of caspase increases as expected because you're under stressful conditions, your cells may undergo apoptosis. When adding the stressful situation and rib, though, the apoptosis or the level of caspase increased dramatically. And they believe this could be due to the fact that if your body is not responding to your integrated stress response, it's not going to eventually go back to its regulated state. So if it continues to just not respond, eventually it may undergo apoptosis. So this is one of the side effects.
And to kind of visualize this, so your rib is said to decrease your ATF4, and it's said to allow protein synthesis to keep occurring. So as we keep synthesizing proteins, more and more proteins are not responding to that integrated stress response in presence of your rib, that's when you undergo apoptosis.
Is that all clear for everybody? Sort of that? Because, I mean, if you look at that initially, it doesn't make any sense. You wouldn't expect your cells to be more apoptotic in the presence of this inhibitor. How about somebody from the audience go through that for us?
Maybe if like you make more of the protein than your cells, like wondering if it might like over accumulate, so then would that trigger some apoptosis?
So think about what's the very first step when you have the integrated stress response activated. In your cell, the very first thing that it does is shuts down protein production. Because you have all these misfolded proteins, you don't want to waste energy basically causing more and more proteins to be produced when they're all just going to misfold. You know, there's no sense wasting all that material. So you downregulate that, you upregulate all of these sort of regulators to help you fold and basically get the system under control. Now rib, in this case, is inhibiting the ability of you to induce that stress response. So is that going to cause you to have more or less misfolded proteins in the presence of rib? More, if you're stressed and you have rib, so that's that TG plus the rib, sort of the upside down triangle is that blue. So here you had a stress, you're not able to stop production of those misfolded proteins because you have rib present. So you're going to have more and more of these misfolded proteins. At that point, you're going to activate your caspase cascade to start to say, okay, this cell is there's something wrong with this cell. It needs to go through programmed cell death. Okay, that all makes sense? That's what they described, and I want to make sure everybody that was pretty clear because it's not a trivial thing to get, but good.
Okay, now just to recap where we're at, we've talked about a lot of phosphorylation events and a lot of things that caused other events. So right now, in our presentation and through their research, so you have your PERT sensor, it's activated when you're under stressful conditions, and this causes the phosphorylation of your alpha-2 alpha. Now this increases your ATF4 production. Now once that ATF4 production increases, it is the head of a transcriptional network, and it upregulates your transcription factors, which we talked about, your CHOP and your GAP, and it downregulates your protein synthesis. That leaves you with your naked mRNAs and RNA binding proteins, which eventually leads to your formulation of your stress granules. Now, the stress granules, as we said before, is kind of what leads to your inability to go from your short-term to your long-term memory. So therefore, their next question is they wanted to see what can prevent these stress granules and how these stress granules cannot be formed by inhibiting and looking at the effects of your alpha-2A phosphorylation.
Okay, so they looked at two different ways in which stress granules can be formed to see if it's alpha-2 alpha phosphorylation dependent or independent. So first, if you prevent the phosphorylation of alpha-2 alpha, as expected, stress granules would not form. There wouldn't be an accumulation of mRNA. But also, if you inhibit alpha-4 alpha, which is actually used to go into the stress granules, so it's one of the mRNA present, you would never produce stress granules as well. So they look to see if you look at the pad A or the